a couple of housekeeping things. Remember, this is a live demo. Sometimes live demos don't go so well. So we're going to hope it goes well today. But we've been practicing. I have every expectation it will. The other thing is during the presentation, my presentation to keep me on time is kind of a movie. And so as a result, I will take any questions, but let me just kind of get through that and I'll take the questions at the end. Glad to answer any questions. I'll be here until they kick me off or until the questions stop. So glad to talk about this. I enjoy it. I'm just going to be going back to work after this anyway, so I'd much rather answer your questions. My final plug is drones are really exciting. Some of what we're going to do today is under what's called Part 107. There's some reasons for that. I ended up getting a waiver for some of the things that we're going to do today. And so I just want to make you guys aware that there are a lot of rules associated with operating anything more than about 8 ounces, half a pound. So you really want to look into those rules before you get yourself in trouble. So with that said, let's get going. So right here what we have, and hopefully you guys can see the video okay, we have some shots I took from Alvarin about a week ago. So this gives you an idea of how we use drones, or one of the uses of drones. These shots would be impossible with any other mechanism. And you'll also get a chance here as we go to see a little bit for the Hudson students of the renovation that's going on. You kind of see it there in the background, and then we can, the Milford students that aren't familiar with us, that's the Alvarin farm that you're seeing off in the distance. And off to just about the left-hand side of the frame is actually where this house is and where we'll be launching our drone. We'll be heading out to Alvarin, so you'll be able to see that a little bit later in the presentation. But for now, I just wanted to give you a little brief introduction. I started with the Hills Elementary School doing drone presentations. This was a UAV presentation. It was done a couple of years ago for Hudson students that might be freshmen over at Alvarin. You may have seen this. It was in Miss Liberty's class. So this was really the beginnings of how we were going to try to, bring this into the Hudson school system. Kids had a ball. They were able to use virtual reality goggles and control the camera through their head motions, and they had a great time. I'd love to have you do that today. Unfortunately, with COVID, that's a little bit more challenging. So this just gives you an idea. This is where you get a real virtual experience of actually being somewhere and seeing what it would be like to be there when it's very difficult with any other mechanism. These particular shots were shot over in Derry, New Hampshire, as we were getting ready for that presentation. So next thing you're going to see is this is one of the drones I fly today for my work. This is over at the Merrimack BAE Systems facility. This is called the Matrice 800. We actually, BAE Systems provides sensor payloads for drones. So we do things like figure out where radio signals come from. We do thermal and other things. I wasn't always into drones. I was always into airplanes. Over the years, I've had a chance to fly a lot of different airplanes, which has been great. The one you see in the video is the one I learned how to fly in. That was recovered and restored. And I also had a chance to really have my kids and pass on that, which is much like I like to pass on to you. For the Hudson students, you might recognize those are my 2 daughters, Rachel and Erin, as they went through. They started flying the airplane, or manipulating controls anyways, when they were about 6. They still go up and fly with me today. So it's been a really great experience. But you didn't come here to listen to me. You came here to listen about drones. So a lot of people, when they think about drones, they think about these sci-fi movies where the drones are out destroying the world, or they're shutting down airports because they're flying in bad spots, or other things. There's a lot of positives that go on with drones. Big thing to think about from a career perspective is the FAA's forecast just a year ago was that they would need a certain number of pilots. That has grown immensely as drones have taken over more and more activities and functions in our society. So as you can see here, there's going to be a need for over 350,000 remote pilots by 2023. That's only a couple of years away. Last year's forecast, they thought there was going to be about 450,000 aircraft. Now they're thinking it's going to be more like 800,000 aircraft in just a couple of years. So where do we use them? Well, we use them WMUR uses them, Eversource uses them to inspect lines. We use them in construction to inspect construction sites. Obviously, we use them in movies. We use them in real estate for taking pictures of properties. Law enforcement is using them more and more today. They're providing great help in finding people, responding to calls, and helping the officers be more efficient. We're also using them in firefighting. We'll see a little bit about that a little bit later in the video. Agriculture is a huge area where drones are being used, and they're really helping us produce crops more efficiently and produce more crops. And we'll talk a little bit about that a little bit later in the video as well. And space exploration. That's going to be the first thing that we're going to be talking about is the drone that's going to NASA this year. Medicine. This is something you might not think of. It's a huge market for drones. And finally, something called future mobility, which I'll get into at the end. So to start with the Mars helicopter, NASA's going to send a drone to Mars, but there's a lot of challenges there. It's got 1/100th of our atmosphere. The highest a helicopter's ever taken off or ever flown is about 40,000 feet. The takeoff altitude on Mars is equivalent to 100,000 feet. This has produced a whole host of problems that NASA's overcome through engineering and folks like yourselves solving these problems. So as you can see, the drone is going to operate for about 90 seconds. This is really a proof of concept. It's going to fly only about 500 feet. It's going to take it a day to recharge, but this is going to pave the way for future drones, the ones that are going to be coming next, that will be exploring the planet and giving us vantage points and abilities to explore that we've never had before. So here you can kind of see what the timeline is. It is currently en route to Mars, and it will be delivered there this year. So here's some testing that they did back in 2015, proving that concept. They're actually in a vacuum chamber right now to illustrate or to simulate the gravity and the atmosphere of Mars. Now I talked a little bit about medicine. Zipline is a huge purveyor of drones. They basically fly the equivalent of once around the Earth every 5 days delivering medical supplies. They deliver the majority of medical supplies in Rwanda and now in Tanzania, and they're now working on Ghana is their next port of entry. So they deliver a lot. I'm going to let you listen a little bit to what they have to say about what they're doing in drones. And I will leave you with this. This is one of the people that was saved.
Operating our first system in Rwanda more than a year ago now. We've been designing our next generation system from the ground up, incorporating all that experience of that first operation. And so we've redesigned pretty much everything about the plane and our ground systems to support scaled operations. So instead of being able to do 50 flights a day, we want to be able to do 500 flights a day from a single distribution center. We pull the blood or the medical product for that order, put it in a package, put that package into a zip, and launch that zip.
Controller ready, airspace is clear, slight headwind.
The aircraft weighs 20 kilograms, about 45 pounds.
Copy, spinning motors and launching zipline 138.
It has about a 10-foot wingspan, 3 meters, and it can carry about 3 pounds, 1.75 kilograms. The plane is measuring actively the wind speed and the direction, and so if the wind's blowing in a particular direction, it's going to compensate and drop that package so it lands on the ground right where you want it. We can hit an area about the size of 2 parking spots.
Rich, just confirming you guys can hear the audio okay?
Kind of like a cake box with a paper parachute on top. A fixed-wing aircraft can fly dramatically farther than something like a quadcopter, and that's really important for what we do.
I'm not important.
It can fly faster, it can fly through heavier weather, and the approaches to things like safety are also much easier. On our aircraft, for example, we have multiple motors, right? The plane, if either one of those stops working, the plane flies just fine. We're in Rwanda today, and we're expanding to cover the other half of Rwanda as we speak, and next is Tanzania. From there, we are really focused on solving this problem, access to medical products at a global scale. There's access to medical product problems in the US and in the developing world, and we really want to solve all of those problems everywhere.
So not only are they using drones in the medical realm, but they're using them in a lot of other realms as well. One of the realms they're using them in is law enforcement. So back in 2018, the Chula Vista Police Department was one of the first in the country to integrate drones into their regiment. And in the first year alone, the drones responded to over 1,000 calls. They supported 150 some arrests, and most importantly, they prevented dispatch of 235 units. That is a huge benefit. That means that they're using the police officers in the most vital places and not responding to
We
false
flew
alarms
a drone
areas.
at a lake that's about 10 miles away. We did a simulated call of a man with a rifle in the area, which is a very dangerous call for police officers to go into. It's important that they have the most information possible.
Sarah 1, we have a UAS in the area. We'll be checking.
453 copy.
453 X-ray, we're in the area.
As a chief, when I look at my organization, it's important for me to have resources available so that we can get people the right information and get them to the call as quickly as possible. The officer who is using the UAV can share to those officers that are rolling to the scene real-time information describing if there's a weapon, what the suspect is wearing, where the suspect is, and that way as the officers come into the scene, they're able to go in and deal with the issue immediately.
453 X-ray, do you have the live feed? Alright, there's a subject out of the vehicle. It's going to be a white male, approximately 6 feet tall, dark t-shirt, shorts, and he's armed with an AR-style rifle. He's pacing outside that vehicle. Alright, he threw the weapon down. He's walking. His hands are empty.
10-4.
And Sarah 1, suspect in custody.
So in addition to law enforcement, firefighters are also using this. It frees up manned resources, it's cheaper, and it provides them vantage points, as you'll see with things like thermal cameras, that they can't get another way. So this is a huge option for them to save lives.
With
Again,
the
to be
drone,
more
you can get
efficient.
darn near the same level of capabilities without putting a person in an aircraft, which is incredibly expensive. The drone's very low cost relative to what you get back.
Cameras on the drone give pilots a bird's eye view so crews can see things like the hottest part of the fire, whether or not a fire has crossed a containment line, or if people are in danger. In this training demo, pilots use a thermal camera to see people through smoke inside a 5-story building.
I'm gonna switch over to thermal view, and suddenly now we can see that we have at least 2 individuals inside this room.
Drones can also measure wind speed and direction, so crews can predict what a fire might do next. The California Air National Guard is using the MQ-9 Reaper this summer. It's a military drone that flies for hours to identify where the fire has jumped containment lines and houses in the fire's path. The US government has contracted 4 companies to fly fixed-wing drones to fight fires on federal land. This frees up resources like helicopters for water drops. And fire crews aren't the only ones flying drones to fight wildfires. Some utilities like San Diego Gas and Electric are inspecting the power grid from the sky with drones. These third-party drones have LiDAR on board, similar to the technology used in self-driving cars, and generate 3D maps of potential issues like damaged power poles and lines. In the future, drones may truly be the first responders.
Drones have become incredible tools for helping to create orthomosaics. But what is an orthomosaic? How are they being used? And why would you want one? Put simply, an orthomosaic is a way sharper version of Google Earth. It's a large, map-quality image with high detail and resolution made by combining smaller images called orthophotos. An orthophoto, sometimes referred to as an orthophotograph or an orthoimage, is an aerial photo that has been corrected for lens distortion, camera tilt, perspective, and topographic relief, which is changes in elevation of the Earth's surface. These corrected orthophotos have no distortion whatsoever and a uniform scale across the image. The key difference between a normal aerial photo and an orthophoto is the perspective and accuracy. A normal aerial photo, as you can see here, has a perspective view. You can see the sides of buildings and other objects, and the perspective changes depending on where the photo is taken. An orthophoto, on the other hand, is what is called orthorectified. It is geometrically corrected for this perspective view, along with lens distortion and camera angle, to create a perfectly straight down view of all objects in the frame, as you would see on Google Earth. The precision and accuracy of orthophotos means both orthophotos and orthomosaics have the same quality as maps and can be used to measure true distances. Now, with this measurement and detail accuracy, how are orthomosaics being used, and why would you want one? One of the main uses for an orthomosaic is simply to get an updated view of a large area of land. Google Earth is helpful, but often the imagery is outdated. Your new development project could be finished, a new construction project could be underway, or the landscape could have changed due to natural disasters. Construction firms also find orthomosaics particularly useful. They can get an updated view of their construction site on a regular basis, and they can leverage the accuracy of the orthomosaics for precise measurements. Software programs such as Drone Deploy allow users to measure distance, area, and volume. Construction firms can use these tools to calculate the volume of stockpiles, estimate material costs, and collect other valuable data without actually having to be at the construction site. Software programs can also use the raw data from the aerial photos used to create the orthomosaic to construct 3D models, which is another powerful tool for construction firms. The agriculture industry is also seeing huge benefits from orthomosaics. Specialized drones have multispectral cameras that gather data from specific bands of light, such as red, green, blue, red edge, and near infrared. The added data from the multispectral camera systems, along with the ability to generate orthomosaic maps, allows farmers to get a detailed understanding of their vegetation health with an NDVI, or Normalized Difference Vegetation Index. They can easily see which areas need immediate attention and have a more successful crop season. Along with inspecting crops, orthomosaics are also great for performing aerial inspections of equipment or other facilities. They can be used for inspecting rooftops, solar installations, buildings that are deteriorating, and so much more. Sometimes orthomosaics are even used in legal cases. They can provide the updated and accurate imagery needed for the legal proceedings. And the list goes on. You can use orthomosaics to count trees, monitor forest health, count cattle, determine the number of cars in a parking lot, see the supplies on a construction site, measure rooftops, make annotations, and so much more, depending on the app.
So I promised I'd get to future mobility. So let's talk about where some of the drone technology is going. We saw Dr. Brown back 20 years ago. We wondered where the flying cars are. Well, it turns out the flying cars are here. We just haven't quite heard of them for the most part yet. But we'll just take a quick look at what we're doing with some of this drone technology.
This is what we thought flying cars would look like. But here's what they actually look like. And the reason this is suddenly happening is because of a confluence of technological advances. Composite materials like carbon fiber make for lighter, stronger aircraft than ever before. Better lithium battery technology allows cars to be powered electrically rather than by gasoline. Computer algorithms are removing the difficulties of learning how to fly, and in some cases, giving birth to vehicles that will fly themselves.
So Boeing Next is really looking at what we call future mobility. If you think about what's happened digitally over time, we've become much more of a mobile society through digital mobility, like smartphones and different types of software. But what we believe the next chapter is about physical mobility. So how do people and goods start to move differently, especially in a time where urbanization is growing, traffic congestion is getting higher, and time is becoming more precious for people. And so that's really what's driving us from a strategic standpoint, is how do we really enhance the ability to transport both people and goods differently in the future.
All right. So you made it through the presentation. I appreciate that. There's a lot going on in drone technology. And again, it comes down to, even if you don't like flying them, there's an opportunity to get involved with the engineering, the design. This is really a growing field right now in a lot of different aspects of it. So what I'm going to do is start today by doing another demo. So the next demo I'm going to do is we're going to talk about this little guy. This little guy, I'll try to keep it near the camera. It's called a Tello. So a Tello is a programmable drone. They sell for a little less than $100. And what they allow you to do is to write software applications to control the drone remotely. So I can live fly it, but in this case, I'm going to let the computer live fly it. I'm going to show you how that works in just a second. I'm going to put this thing down, and we'll see if we can share an appropriate screen here. If you just give me a second, if I can wake up the computer, because apparently I let it go to sleep. Come on. That's what happens. You don't keep the thing running. Okay. And so what I'm going to do is I'm going to share my screen so you can see what's going on. Let's see here.
So John, while you're setting up, I have a question for you.
Yes, sir.
So I've got a student in the audience who's looking to go to college for EMS studies, criminal justice, and they are wondering if drones are seen as something that's going to help or replace people in that field. What's your take?
So for one thing, I will tell you that law enforcement, if you have a Part 107, which is a commercial drone operator license, which is really just a written test for the most part, so it's nothing worse than what you're used to in schoolwork, that's viewed as a plus because law enforcement officers are incorporating drones to make their jobs safer and to make their job more efficient. So by dispatching a drone, looking for people, again, using thermal cameras and other things, they can coordinate with other officers to enhance the safety and situational awareness of situations they may find themselves in. They can also send drones, again, into places where maybe the officer might be at further risk, being able to get that situational awareness, seeing what's going on, and understanding what they're walking into is just helping them to approach a situation safer. And again, providing them some valuable tools. So a drone to them is, I don't think, a replacement so far as it's just another tool in their arsenal or a tool in their tool belt, if you will, in order to get their job done efficiently and effectively and safely. And so I think really if you're looking at going into law enforcement, just, not necessarily trying to say that drones are the end all be all, but what I was saying, I think, to a conversation with Rich earlier is, it's a differentiator. If you're an applicant and you happen to have a Part 107 and that police department may say, hey, we have drones in our department, we would love to have somebody that's familiar, that's able to operate them, is legal to operate them, and that may be something that differentiates you from your fellow applicants. So that's something that you can just think about as you think about a career in law enforcement. Hopefully that answers that.
Yeah, thanks, John. And we'll kind of save some of the other questions for at the end. So we'll let you do your thing.
Hopefully folks can see my screen okay. Yeah, I should be sharing. So on here, what I've got is just a really simple software program that we're going to use with this drone. So in this case, what I'm going to do is I'm going to tell it to go forward about 100 centimeters, turn left, go forward, turn left, go forward, turn left, go left, forward, turn left. So I'm basically going to fly it in a big box, and I'm going to tell it to take off and land. So this happens to be written in Java, but for those computer science students out there, you can interface this drone with Java, C++, Python, a whole host of different languages. This just happened to be easy. So what I'm going to do next is I'm going to flip on the drone here. I think it shut itself off because I talked too much. And then we're going to command it. Now, what you're going to find out when we get here is as this flies, there'll also be on-screen pictures, so you'll be able to see exactly what it's doing. If I can just get here, I just got to log into the drone. Hopefully it'll show up here in just a second. There we go. We'll connect up with that. Yeah, connect, please. Come on. There we go. So as soon as this connects, we'll send it on its way. And so this is, right now we have a lot of competitions and other activities that students can get involved with that leverage the ability to autonomously program drones and to come up with creative programmings to accomplish particular tasking. So I just offer that as something interesting, some way of incorporating drones into a computer science curriculum. And again, when we look at what industry is doing a lot with autonomous control with drones. We're going to talk a little more about that. So here it goes. Hopefully it's not too choppy on your screen.
Looks great.
And so it's going to, basically, it's currently going through that program you saw on the screen. It went, it turned left. It's going to go a little farther, turn left again, go forward, turn left. Really exciting stuff, I know, but hopefully this shows you some of the potential for where this can go and what you can do, again, for something that's a $100 drone. So this gives you some idea of where we can get with the programming. So I'm going to move now from the Tello onto something a little bit bigger. And so what I'm going to do is I'm going to move over here, and I'm going to talk to you a little bit about the flight plan that we're going to run today. And hopefully I just got the screen capture back. I did. Good. Hey, this is good stuff. So I apologize. I would have walked you through this. I just didn't think we had the time to do it. So here's the flight plan I set up today. So this is a program called Litchi, and it helps to autonomously control a drone. So here what we can see, if I scroll down a little bit, there's Alvarin down there in the distance, down at the bottom of the route. Now you'll notice that my route, I keep us pretty much over trees, forest, uninhabited areas the entire time. And the reason for that is what you want to do is the FAA says you don't want to fly over people, cars, property, anything where the drone could cause a problem if for some reason it lost power, if it went down or something to that nature. So you'll notice we stayed clear of anything else. You'll notice that near all these little like bubbles that have numbers on them, those are waypoints. That's where the drone is going to fly. And the number above it tells me how high in feet it's going to be at that point. And so you can see we take a pretty safe altitude here. We're going between 200 and about 360, 70 feet. Drones have to stay under 400 feet. It's an FAA rule. We will be staying under 400 feet today. In addition to that, you'll notice that I have these other things that kind of look like cameras. They're not connected to the lines. Those are point of interest. So why is this important? Here's where, if you're a photography student, or if you're somebody that's into cinematics, or you're using the drone for particular purposes where you want precision, basically I'm going to tell the drone where to point its camera. It's going to use all that cool trigonometry that you guys learned. It's going to use all of that to figure out where to point that camera to focus in on the point of interest that I've specified while the drone is moving. So it's going to recompute that, it's going to move the camera, and you'll be amazed at how smooth it's going to be able to do that manipulation on the screen. And so this is where a lot of the autonomy comes in, and where we manage these flights and where drone technology is going, because this allows us to really center in and get exactly what we want. So now that we have talked a little bit about the flight planning, I bored you enough. Let's go see if we can fly this drone to do it. So today, for this particular exercise, we're going to be flying something called a DJI Inspire. It's a relatively reasonably good-sized drone. I'm just going to flip on power here, and then we just need to quickly flip over to the other video feed so you can actually see what the drone is seeing, and we'll see it actually run that mission. So if we can just flip over, hopefully we got a picture. Oh, there we go. Good. That's the one. Oh, yeah, you should be able to just tell it to cycle that up. Sorry, everybody. As usual, I said live demos always have challenges. Okay, so now you're seeing what the drone can see. And so now what I'm going to do is we're going to go ahead and launch this drone on this mission, and everybody will be able to see it fly those coordinates that we just talked about. So here we go. We're going to start it. We did a check of all the drone systems. Area is clear, so I think we are now on our way. Unfortunately, I can only show you the camera on that screen. I was trying to work at giving you the overall map view as well so you could actually see it fly the waypoints, but I have that on my screen. I just couldn't easily get it up on the share screen for the computer, unfortunately. Okay, so the drone is going to figure out where it is, and then it's going to start its mission. So its first point of interest, as you'll see here, is it's going to be focusing on this sand pit out here in the back. We kind of looked at that as it flew by. And so you'll see the camera is pretty darn steady, and it's focused right on that sand pit. For again, I'm not flying it at all. I'm just monitoring it, making sure that it's doing what's supposed to. I'm watching its altitude and making sure that it's staying within the parameters I specified. And so it's now going to go to the next point in its mission. So there's like a beaver pond out here just on the outside of the Alvin field. So we're going to be flying over that, taking a look at that as we go by. And then we will be transitioning to actually look at some of the areas in Alvin itself. So there we go. We are coming by the beaver pond. We got Alvin in front of us. It's going to be taking a little bit of a right-hand turn here as it curves around, stays along that tree line. And we'll be able to see, you can see the renovation that's being done at Alvin on the farm as we go through that portion of the mission. It might get a little bit blocky once we get all the way out there. It has to do with the fact that I'm trying to get through a couple of trees on the signal, but it looks like it's holding pretty well right now. So there we go. You can see Alvin High School. We're now in that bottom corner of the mission. And folks don't realize it, but it's actually recording all of this as it goes. So I actually told it to go ahead and record the whole mission. So yeah, there's just, you might see a couple of just blockiness as it gets on that one point, and then it'll start its way back. And so now it's on its way back from Alvin back here. It's going to stay focused on Alvin as we pull away. And then eventually it will resume looking out towards the farm at Alvin. Once it gets a little bit further here, because I've given that a different point of interest. And so right now it's, the drone's flying at about 15 miles an hour, so it's not flying overly fast. The drone is capable of flying somewhere between 35 and 40 miles an hour, but right now it's about 15. So it's now coming back across that mission. Now very soon it's going to be arcing back to come back and land here at the house. I don't know. Oh, can you guys still see the screen okay?
Yep, looks great, John.
Okay, because Tracy just asked me whether or not. So there you can see the house is coming back into view as it returns back to its home. At this point, it's ended the mission, and so what I've told it to do is once it gets done with the mission, just stay there. And what we're going to do is get this drone right back on the ground here quickly, and we're going to move on to the next thing, hopefully. So we'll just quickly bring it down. You'll notice I'm still flying forward. Just random aerodynamic thing is helicopters have the same problem that you don't want to fly through your own downwash.
it tends to make the aircraft very unstable. And so you want to maintain that forward movement all the way down to the ground. This drone actually has a landing gear that comes down. In fact, I'll swing the camera around so you can see it. Let's see here. And so I had to wait for that to cycle down before I could land it. If I can, maybe I can't get it in view here. There we go. It's kind of out there. So now that that's in view, we'll go ahead and bring it in and land it on here, and then we'll move on. Okay. So you can see how we use drones to complete these types of missions. And as you can tell, they're pretty effective at it. So now what I'm going to do is I'm going to move a little bit onto some of the stuff that we're talking about with race day. So as part of drones, we thought it would be really cool to come up with a competition that you guys could get involved with that still didn't break all the COVID rules and other things. So what we decided on was a drone competition. Now, the schools have some drones. They're going to select some participants, and we're going to go through a race course. So today, to show you what that looks like, I've got a little drone, and actually I'm going to stop screen sharing for just a second so you can actually see what this thing actually looks like, other than a little bit of a staggered video here. Let's see here. We'll take care of that. So let's see. Let me just stop sharing for just a second the screen so I can go back to this. So this is a little drone. So this is really small. I'm going to see if I can get. Hey Tracy, can you pick up that one race gate, please? The one that fell over. So this is the one that we sent to the schools. You can see it's similar size to what I'm going to operate today. Only difference is this one's got a camera, this one doesn't. So you guys can actually watch what we're going to do when we go through on race day. So I'm just going to pop this guy down. And what we're going to do is we'll get him started. And we'll let you guys see what it looks like. All right. So off he goes. So you'll notice that in this case, the video is not what you're used to. The reason for that is this is old analog video. This video, goes back to the days of the 13-channel televisions and so forth. So let's see here. What we're going to do is try to get us on race course. So on race day, what you're going to find is that you're going to have a few of these gates laid out for you and land your drone. So you'll start before the green cones, fly through gate 1, through gate 2, and through gate 3, and finally through gate 4. But you'll go through 3, 4. It's again a drone similar in size, and at the end of it, it'll be timed. So, and all you need to do is land after the red cones.
If you'd like, what we could do is we could just kind of take a minute here, and I can kind of walk, or we can walk everybody through the challenge and that type of thing. They were able to hear you. They just could not see the drone going through its paces out in the course in your backyard.
Oh, that's unfortunate, but yes, let's do that.
Okay, great. So if you want to talk a little bit about the challenge and maybe talk about the course a little bit. I know you know what the size is. It's not very big. How many obstacles that students will have to go through, and then I can chime in with the rest.
Okay, so yeah, it's a very simple course. There's going to be a set of cones. So when you come into the facility during the time that you're supposed to be there, I'll be there. I'll stay well away from you, but when you come into the facility, there'll be a set of green cones. Just start your drone behind the green cones. Go through gates numbered 1, 2, 3, and 4. You can stand anywhere you want. You can stand next to your drone. You can do whatever you'd like. Run through the course. I'm asking that folks take no more than 2 practice laps. Again, stopping at the red cones after you get through gate number 4. And then there'll be an opportunity to do 2 timed laps. We'll take the best of the 2 timed laps, and I'm going to combine all of the best of the students from each school, average those together to come up with a final winner. So that's the plan for the course. And again, just when you're ready to take your real laps, just give me a high sign, let me know, and we'll get underway. We're planning
Doing it next Wednesday. Right now, the forecast looks okay. I will tell you, with these little drones that are this size, if you get a lot of wind, they don't fly so good. So we're going to have to keep an eye on the wind and the weather to make sure that we can be successful. So that's the only caveat. If we can't go next week on Wednesday, we'll go on the following Wednesday.
Right. So let me kind of fill in the folks that are listening in on this about the details and the logistics and that type of thing, and then we can answer some questions. So I'm going to throw up on the screen here, put on the screen here. I think I had it on there earlier. This is the Hudson Milford Drone Challenge, as John was talking about. It's going to be next Wednesday, May 13th. So for Hudson students, so for Alvin Hudson Memorial students, we're going to be doing this in the parking lot at Alvin High School. We're going to find a little sheltered area, hopefully reduce the wind. It'll be from 11 a.m. to 1 p.m. We will send everyone, both Hudson and Milford students, a scheduled time for you to show up. We will provide all details if your name is selected. From Milford, we're going to do it in the Milford High School parking lot. It's going to be from 8 a.m. to 10 a.m. And again, students will be scheduled every 15 minutes. As John was talking about, being able to do a couple of practice runs and a couple of timed runs, really only going to take about 5 minutes. What we'll need students to do if you want to be involved in this, and I will say this again before we end today's webinar. Hudson students, you will need to email me. You should be able to see my email there on the bottom left-hand side of the screen, rpiva@sau81.org. If you would like to participate, you have until the end of today. You have until midnight tonight to actually email me and say, I would love to be involved in the drone challenge. And again, as part of the drone challenge, if you're willing to sign up and your name is being drawn, we're going to draw names. 9 lucky students will get a drone. So in earning a drone, you have to compete. That is how you earn your drone. You will actually get to keep your drone that Mr. Stevens and BAE Systems has been kind enough to supply us with. For Milford students, you're going to email Jen DeMaria, Miss DeMaria, the career development specialist there, at jennifer.demaria@milfordk12.org. So you may actually want to write down those emails and be able, again, all you have to do is put something in the subject line about drone challenge and give me your full name and give Mr. DeMaria your full name and be able to simply say, I want to participate in the challenge. First thing tomorrow morning, we will draw names. We will randomly draw names both from Hudson and Milford, and 9 lucky contestants from Hudson and 9 lucky contestants from Milford will be notified first thing tomorrow morning, and we will tell you what the process is to pick up your drone. You will have the entire week to practice. And as you saw from Mr. Stevens, these drones are easily able to be manipulated inside and outside. Probably, something you want to think about, especially if it's windy outside, to do something inside, or if you don't have a big space. But as John was alluding to, the course is really only 24 by 36, and that'll give you a few days to practice. I think that's most of the details for the challenge. What I'd like to do now is just kind of go through some of the questions that were posed, and maybe John, you can kind of answer that. Somebody had asked about how do you go about getting one of those drone pilot license?
That's an excellent question. Just to finish up on your thoughts, Rich, there is also a video I shared with you,
Yes.
Rich, that kind of does a how-to, and it actually walks through the course that we shot over at, we shot the footage over at Alvin. So to answer your question, Part 107 FAA license is a commercial drone operator license. It's a test. So some of the school systems are actually giving people some of the educational material for it. it's really, you can look it up online, and maybe I can work with Rich and we can see if we could even arrange some ground schools at the high school at evening or after school once we get back to normal. And you take the test. You have to then pass a flight test with a FAA designated examiner. It's not a incredibly difficult thing to do. Basically, they want to make sure that you can safely operate your UAS system. That's what the FAA calls them. Your UAS system. They want to make sure that you have the appropriate knowledge to operate it safely and in compliance with the FAA rules and regulations. It's not a big deal. Once you have your license, then you have to renew it every 2 years. The license enables you to operate drones for commercial purposes. That means that I can operate within the confines of the National Aerospace System, within the rules set forth by the FAA. I can apply for waivers and other things. So I can do things like, for example, you can't fly drones at night, but I can apply for a waiver as a Part 107 holder that says, hey, I would really like to drone this football game. I'm going to stay over the field away from people. Well, not over the football field, but over a field next to it. I'm not going to be near people. This is what I'm going to do. This is where it's going to be operating on, and so forth. And the FAA can then come back and say, yes, we grant you that waiver. We will allow you to do that. Even though you're not supposed to fly drones at night, you can for this particular purpose. So again, that commercial operation allows you to collect money for your services. It also allows you to do things that you wouldn't normally be able to do within the rules that the FAA has set forth through waivers. And again, from a commercial perspective, drones, I actually have friends that I work with that have drones that they use for agricultural surveys, for surveying golf courses, for doing all kinds of things that they basically use their drone for. And in order to do that, any type of commercial thing that they're getting paid for, you have to have a Part 107 license.
Great, thanks. How do drones play a part over at BAE Systems? Maybe you could talk.
Sure, absolutely.
About that.
So BAE Systems in New Hampshire, so BAE Systems worldwide does all kinds of things, but BAE Systems in New Hampshire, we do a lot of sensor systems. So that means basically things that detect things, detect radio frequency, detect infrared. So think about like thermal cameras. We actually make scopes for some of the military weapons that soldiers carry. We operate sensors that exist on most of the aircraft that you see in the military. So all of those systems, basically, we host on a drone. In addition to that, we work on something we call M2CS, which is multi-mission, I think, coordination system. I'll get the acronym wrong. Somebody's going to kill me for it. But basically, this is a flight management system, which just like you saw us do an automated flight, we work on software packages that don't allow a single automated flight. They allow hundreds of automated flights all simultaneously to accomplish specific missions. So our users, whether it be the military user or a civilian user or a government user, they're using multiple drones to accomplish a mission. They want to be able to coordinate 4 or 5 of these that have different vantage points that might act as communication relays or help search for somebody in unison together. So we work on systems that basically help drive and manage those individual components. So that's kind of how we use them right now. Right now, one of the programs I'm working on happens to be for the government, and it basically enables 4 or 5 drones to work in unison to locate a radio signal. So think like your cell phone. So basically the drone would be able to figure out where that cell phone is and kind of zero in on it pretty quickly.
All right, so we got a couple more questions, but I know we're hitting like that hour mark, and I want to make sure that everybody has the information for the competition. So one of the questions, John, was the drone flyover that you just did. students could actually see the battery actually reduce on the drone, the battery power kind of go down. It seemed to go down pretty quick in that short flight. Is that typical? It looked like it would go down 1 or 2% every 20 seconds or so.
That is typical. Most of the drones, most of the commercial drones have about a 20, sometimes as high as a 30-minute flight window. So the drone that I just flew, about 17 minutes is the flight window. We typically don't push it beyond about 13 minutes. We usually want to keep the rest of that in reserve just in case something unexpected happens. The particular drone that I just flew, the reason for that is it's carrying a very heavy camera. It's not the typical camera that you would see. You actually saw a very low resolution output of that camera. That camera is actually filming at full 4K cinematic quality. So that's what's basically, it's all that weight that's causing that flight time to be pretty short. There are hybrid drones which incorporate both a gasoline engine with an electric generator as well as the electric motors that exist on the arms. Those can have flight times of several hours. In fact, the ones that BAE Systems that I fly for them, those are hybrid drones. Unfortunately, I couldn't give you pictures of those, but those are hybrid drones. They basically have a gasoline engine that creates the electricity that fuels the electric motors. Oh.
Great. John, I was going to ask you, is there any way to be able to show at least the students and everybody in the audience the course that you've got out back? May not have time to fly the drone through it again or the battery power, but I mean, at least be able to see the course so people can get a better picture.
Oh, absolutely.
Possible? Yeah?
Yeah, we can do that. Let's see if you can, yeah, we'll do, what we can do with this. We'll just, yeah, just plug that in.
And while you do that, I can actually kind of go through the competition a little bit more. So I'll put up the slide that has Miss Di Maria's email address and my email address on there again. And again, if you want to participate, we'll go through the process of you emailing us. We'll put you into the drawing for the drone. You have until basically midnight tonight, because tomorrow morning we'll pull names, and then we will notify you tomorrow morning as well on how and where you can pick up your drone. Again, for Hudson students, it's going to be at Alvern High School. For Milford students, it'll be over at Milford. We'll supply you with the practice video, and you'll be able to practice. You're going to get batteries. You're going to get a couple of rechargeable batteries. You'll have everything you need to be able to practice. And again, practicing is really being able to do, you know, up, down, landing, taking off, left, right, that sort of thing. You don't actually need to have the course in your backyard to be able to practice and be able to maneuver the drone. And you'll have several days to do that because, again, we're looking to do this on Wednesday, May 13th.
All right, I'm ready. If you don't mind me, I will share my screen again, or attempt to. Hopefully this will go well.
Go right ahead.
So hopefully you guys can see it okay?
We can see your you can see your desktop with the zoom on it.
Oh, really? That's not good. Hang on a second. Let me just see. I apparently shared incorrectly. Let's see here. Where is that? No, go. Do I still have you, Rich?
Yes. Yep. Still here. We just the only thing we see is your entire desktop screen.
Oh, well, that's terrible. How would I do that? Oh, stop sharing. Let's try this one more time. Again, live footage always seems to be
yeah, if you should be able to hit share screen and then pick
I think
one of the options.
So now you should be able to see.
Yes, we see the backyard. Yep, we see the drone.
So if you give me just a second here, we'll give you a better view of what this looks like. So there we go. So now, let's see here if I can give you guys a better view of what this course looks like. So there we go. There we go. So what I'm going to do here, we'll get us down to where we can actually see it. So hopefully you guys are getting a good picture of this.
Yeah, it looks great. Can see the start, ring 1, ring 2.
Yep, so we're going to go ahead. I'm not going to fly this. This one's a little big to fly through those hoops, but we'll fly it over it. You'll get to see what we're looking at here. So you'll go 1, 2, and then what we'll do is we'll spin it around here, and then you'll, oh, I went too far. Sorry, we'll pull that back a little bit so you can see better. So then we have gate 3 right here, and then you'll be able to see to come through to gate 4. And then there'll be a set of red cones at the end, and you'll just have, so you have to take off before the green cones, land after the green cones. Whoa.
Great.
So that's really it. It's very straightforward. And again, yeah, you can stand anywhere, you can walk through it with your drone. So some people, say, well, geez, how can I even see where it is when it gets up near that hoop? But you'll be able to walk through it. That's no problem whatsoever. So that's, so again, pretty straightforward. Any other questions that I can answer?
No, I think that's pretty much it from the audience for the most part. And what I'll do is we'll just, let me throw up my screen to be able to, again, show everybody.
Yep.
Yep. So, again, everybody that participates will be able to keep their drone. This is how you earn your drone. You'll be able to pick it up on Thursday if your name's being drawn, and we will email you if you're a winner first thing on Thursday morning. What's the name of the drone that students will be getting?
This is called a Holy Stone 210.
Okay, a Holy Stone 210. All right. Again, it's a small drone. It's easy to use inside or outside, and you'll have the week to practice. So Hudson students, on the screen, you should be able to see my email address, rpaiva@sau81.org. And then Miss DeMaria is jennifer.demaria@milfordk12.org. Email us to participate. We'll provide you with the video, we'll provide you with the batteries, the remote, the drone, everything you need, and we will schedule everybody 15 minutes apart. So we'll practice good, safe social distancing, and we'll have you be there for your runs, and then we'll have the next student scheduled to come in both at Alvern between 11 a.m. and 1 p.m. and Milford 8 a.m. to 10 a.m. If anybody has any questions, you're more than welcome to email either Jen or myself about the challenge or what you saw here in the video. And I just want to say thank you very much to you, John, for helping us out. And there was a great presentation, and I think there was a lot of great information, and it seemed like a lot of students got a lot out of it. So I just want to look real quick. A couple of other questions. So the competition is for 8th through 12th grade at both schools. And then for the obstacle course, I assume that students will take off from the ground, fly through, and then they'll have to land their drone. Correct, John?
Correct. So that's where we're going to time it, from the time that you take off, leave the ground, to the time you return to the ground.
Beautiful. Awesome. All right. So I think that kind of wraps it up. I think we covered everything. And again, thank you very much for joining us. And John, thank you very much for sharing your expertise and your knowledge and helping us out with the competition. If anybody has any questions, just email Jen or I. And with that, I will say adieu and enjoy the rest of your day, everybody.
Thank you very much, everybody.